Welcome back to Chem 330 Week 2 discussion on alkenes. In the previous video we learned whether a compound that's given has got a double bond or not, and then we also learned how to determine how many there are, if there are any, right? So let's just follow up with one more example. So let me get my pen. It's C20H40. Say if this is the compound. All right. As I said, to determine whether the compound contains a double bond or not in the first place, all you have to do is go get the alkene formulae, which is CnH2n. This is for an alkene, right? Right. So we put N as 20. Okay. So that means we get C20H40, right? Well, we get our formula back. So yes, the compound contains double bond. Okay. Typically, you won't find too many compounds with too many double bonds, but there are compounds that do contain them. So to figure out, okay, we did establish that our compound does contain a double bond, so we have to figure out how many there are. So we're going to call this compound that is given to you as given. Okay, and you have to figure out the parent compound for this, right? And that's nothing but you have to use the alkane formula. Alkane, not alkene. This is alkane. You do, however, have to use the same 20 to do that. All right, so C20H42, right? This is the parent, right? All right, so how do we figure out how many double bonds there is? As I said, all you have to do is, okay, put your parent at the top and put the given at the bottom, right? H40, right? And then you subtract this from that and you divide it by 2. Remember, I said this 2 is constant. It's always divided by 2. No matter what the number on the top is, the number on the bottom is always going to be 2. So let me emphasize that. This number is always going to be 2. Okay? So what does that mean? We get 1. 1 means you do have one set of double bond. That's what it means. Right? So let's go write a couple of isomers for it, and then maybe, or at least learn one more time how to name these. All right, so let's find an easier compound. C20 will be a long line. All right, so let's say C8, okay, H16. So I have established this to you that this is an alkene, okay, and I'll tell you there's one double bond in it. Okay, so now your job is to find a cup, write at least 2 or 3 isomers and then name them. This is a way I might test you because it's not realistic to write 60 different isomers. Alright, so let's write 8 carbons first. 4, 5, 6, 7, and 8, right? Alright, now we do know there's a double bond, and it's always customary to start from this end. Alright, so let's get our blue. Okay. As I said, you gotta anchor it until and then you move the double bond within that chain before you even go to the next set of chains, right? So this is our first one, right? So that means I'm done. I can go ahead and write my structures up, and this is what I should have had, right? Now we're not done yet. Okay, we can still use this anchoring point and keep moving double bond around. All right, so within this chain. All right, so let's go get our black back. Okay, so C, that's 4, 5, 6, 7, 8, right? All right, now we move the double bond here, we can move it here, right? and then we can move it here for the next one. So you got to explore as many combinations as there is for the 8 carbon chain before you even consider moving to a 7. Now, like I said, I will give you a choice on a homework if you were to do it, that I will just tell you how many I need rather than telling you to write all possible, which is going to be extremely time consuming, and that's not the point of the learning here, right? There we go. There's 1 and 2. But it's not so much the isomers at this point, it's definitely the naming, right? All right, so 8 carbons, right? From our knowledge, we know it's a octane, right? All right, so that means we know the compound contains a double bond, so we replace the A and E with E and E, right? So it is now octene, right? All right, so that's our last name. All right, now we have to go for the numbering, right? So it's 1, 2. As I said, you always start from the side that contains the double bond. So that's easy. So at least that you won't forget that. So it's between 1 and 2, right? And I said the number with the least value gets the preference, so it's the 1, and so it will be 1 octene. Because there's no substituent, you don't have to worry about any of this. If you do the same math for here, it'll be 1, 2, 3, 4, 5, 6, 7, 8. It's still 8 carbon chain, but the double bond is between 2 and 3, so it's 2 octene. Does that make sense? Yep. So that is how you name alkenes compounds. All right. All right. When I come back, I'm going to have a discussion on alkynes, which is the last part of this section. All right. Stay tuned.